So, having said that, my name is Dave King. I have been recently appointed as the leader of the North American organization for Valmet. I've been in position roughly 4 or 5 months now, and looking forward to moving our North American organization forward and collaborating with a great set of resources that we have in place already in North America. That said, I'd like to give an overview of Valmet today, just briefly touch on the things that, the resources and so forth that we have in R&D, taking the next steps in services in North America with the huge installed base. Service is a primary focus of ours, and then just a couple of words on some recent orders and startups. Valmet today, I think that probably most of you in here have known Valmet over the years. We've been in existence for over 200 years in one way, shape, or form, and here you can see the many names that have been Valmet, mergers, acquisitions, and so forth. I wouldn't go into all of this, but I think it would be important to note on the right-hand side of the slide, you can see that in 2013, we were then Metso as a big group, included mining, minerals, flow controls, quite a big company. We demerged. We felt as though there was an opportunity to set a better direction for the pulp, paper, and power part of our organization. When we demerged, we kind of reacquired the name Valmet, seemed appropriate because of the history and so forth. So we began our existence as the new Valmet then. From there, 2 years later, we actually acquired the automation portion of the Metso business, and that was a great opportunity for us to put back some of the solutions that we were offering before. So we feel as though we have a much more complete offering, not only in new equipment, but also in the aftermarket services. And in particular now, Seihan will talk in more detail about, the Internet of Things and, our remote solutions and things like that. Quite a hot topic in terms of improving operation. In terms of our business, Valmet is roughly a €3 billion company, a little bit more on the orders received in 16, a little bit less on the net sales side. We had about 200 million euros in EBITDA, which equated to about 6.7%. Our goal now is to increase to the story that we go to the stock market with is we want to be an 8 to 10% company. We have, since we've spun off, grown every year in terms of our profitability, and we expect to do that as we develop the organization further. You can see in this middle section of the chart that we have 50% of our business in what we call the stable businesses, and then we have 50% roughly of our business in the capital businesses, new mills, new machines, new large rebuilds, and so forth. The reason that the stable business is highlighted is because that's where we really want to push and grow. We think there's a lot of opportunity for us to bring our solutions to you. We think we have a lot of great solutions to improve performance and reliability and so forth. You'll hear more about that, I think, as the presentations go on, but also into the future. In terms of geographic breakdown globally, Europe is our biggest market, close to 50%. North America is second with roughly 22%. We float around 20% year after year in terms of depending on how cyclical the capital business is and how these stable businesses continue to grow. I think that our offerings in general. We're offering a host of solutions, equipment, and so forth across pulp, paper, and energy. And generally, we feel as though we're, if not number one, right in the top of the spectrum in terms of what we offer. And again, foundationally, service and automation we're very focused on in terms of bringing those solutions into North America more and more. We like to think of ourselves as a process technology supplier, but of course, again, just to repeat myself, we're very focused on service and automation. We bring all three corners of the triangle together for providing solutions. As I said, we are a global company. We're broken down into these 5 regions, and you can see that we've got quite extensive coverage, offices, R&D centers, and so forth. In North America, we have about 1,300 employees. We have 17 service centers, some production centers, and sales offices scattered across North America. We are very proud of the fact that we're recognized as a company that's on the Dow Jones Industrial Sustainability Index. The second year we reformed as Valmet, we are acknowledged for that. We take pride in building sustainability into our designs, but also the way we operate. And we are seeing across the world, really, our customers are not expecting it. They're demanding that we are operating in a sustainable way. And as well, we want our sub-suppliers to operate in a sustainable way. In terms of research and development, as I said, my colleagues will, of course, talk about this in much more detail in their presentations. I would just say that we have 16 R&D centers. We spend more than 60 million euros annually on the development of products and solutions. We try to focus on gaining insights from our customer base in terms of what are the needs, whether it's performance enhancing or reduced maintenance. But at the end of the day, it's all about producing a better product for lower cost. And that's what we're trying to achieve. Taking the next steps. I mentioned that service and these quote-unquote stable businesses are very important to us. We've formulated a campaign which we've titled Shared Journey Forward. And I think you'll hear more about this as we develop the program, but it basically has a couple of components. The first is kind of our core commitment, and that's on the left-hand side where you can see safety comes first. We want to be close to you, and that means physically with our resources. It also means mentally we want to be aligned in terms of what's important to you. We want to bring the solutions that you need. We don't want to try to develop solutions that don't make any sense for you. And we want to bring people to the table that you can trust. Obviously, we have hiccups from time to time. It's how we deal with those hiccups that we want you, to take away, that you've got people that are going to stand by our products and services going forward for the long haul. We've shaped our offerings into really 3 kind of general categories: reliability, performance, and new technologies. Kind of broad categories, but here you can see kind of an example of the types of things that are we consider in these categories, all the way from spare parts and components through consumables, over to process automation solutions, remote solutions, and as Saihan will talk about the Internet of Things and how can we bring that to you to improve the way you operate. So just a couple of words before I turn it over on recent orders and startups. Here you can see this is just a sampling of some of the things that we're doing here in North America. The first 2, Kruger and Sappi, are grade conversions, extensive grade conversions. I think that's an industry trend right now in terms of what grades some of the companies strategically want to move in and out of. The third example is a digester plant it's under construction right now in Clearwater, Lewiston. That's our compact G2 pulping system. Then we have a couple of examples of tissue machines, Sofidel and Paper San Francisco, which the tissue market has been, of course, quite active globally, but as well in North America. And then confidential, we're not yet at liberty to announce the customer, but 3 good-size board machine rebuilds. And I will say that Mike is going to talk about some of our cases in a little bit more detail. Then recent startups, just a quick list. The first 2 are tissue machines, board machine rebuild, another compact cooking system up at Irving. We just completed a fluff pulp conversion at Domtar Ashdown, and then a number of rebuilds and upgrades and so forth. So just again, an overall sampling of some of the activities, as well as, of course, our ongoing service and stable businesses. So kind of in a summary and conclusion, we would say that North America really is quite active, particularly when you talk about grade conversions, upgrades, but also new machines. We see that the investments are stronger, and I know that this is kind of general in a sense, but the investments are stronger in tissue and board and declining in newsprint and printing and writing. I think everybody probably in this room knows that already. We are continuing as Valmet to invest in the things that are supporting the market, supporting the demands of the customers. We're doing that on a global basis, of course, but we're trying to focus in North America because North America is a mature market and has its own set of needs and so forth. And then again, developing our service offerings for that big installed base in North America to make you more competitive. So really with that, I'd like to, again, thank everyone for coming out this morning. I want to thank everybody that is online. Appreciate that. And I think we'll save questions and answers for the end. So thank you very much. And Seon will now talk a little bit about improving performance and the industrial internet. It's, I think, a very hot topic. Whenever I go to meetings with corporations, corporate customers, one of the first things I ask, what do you guys have that's going to help me moving into the future? So, Seon.
Okay. Thank you, Dave, and good morning, everyone. So, as you already heard, I'm going to discuss industrial internet and our remote services. Particularly, I'm going to focus on the performance side of industrial internet. That's where we are most engaged in. We have actually, as you will see, in terms of remote connectivity and everything, that's almost, a story of the past. So, first, I think you've seen the triangle. The triangle comes very handy when we talk about industrial internet, because what industrial internet means to us is really it's the integration of people and machinery with our network sensors and applications, which is depicted here on the bottom left-hand side. So if you think about the needs, it's really in the connecting the data at the right time and recognizing the urgency of the data, what it means, so that good decisions can be made. And we use that connectivity for optimizing the processes that you worry about. So that's really what it means to us. And we have all the pieces to really be able to develop industrial internet in the direction that we feel is most useful to you. Process technology, services, and automation, and all really feed into this solution. So today we actually have already quite a number of applications in place. As you can see from the numbers here, we've supplied 780 lines with Valmet automation platform, 380 condition monitoring, and with over 70,000 tags, 350 advanced process control installations. And there, especially the performance side is very important. They all have remote connectivity, and some of the industrial applications, applications of industrial internet infrastructure is already there. And 90 performance agreements with remote connections. And finally, and this is the piece that I want to focus on a little bit, and I specifically said co-creation here of advanced analytics with customers, because this is not just done by us. This is where we need to work together to advance the analytics part of it. And that's where we are heavily engaged in now. We have done several applications, but most of them came as a driver for our business where we see the need. But now is the best time to cooperate in this area and hear some of your needs. So another view here, looking at the advanced automation analytics and utilizing that for value-adding services. We already have the process technology. We have the automation and IT platform in place. And now our focus area is application and services, more in terms of analytics. Of course, these applications we have supplied on machine applications for a long, long time. And we've connected that remotely. How do we take that another step further? That's where we are heavily engaged in now. And ecosystems, that's mostly collaboration with partner network. That's a priority for us as well. So this is yet another view here, value generation through different levels. Expert support solutions we have been doing, as you saw from the numbers. We have expert centers. Most of our installations are connected to 24/7 to experts available to serve you. Analytic solutions, they exist in the level of where we could bring them, but now we need to do more of that. And on-machine solutions, of course, have been there for some time. So I'm just going to take one of them and then elaborate with a few more examples of industrial internet applications. This is the remote centers, which are really the engines to digital services. And there we have quite a number of installations, 780 lines, where we supply, as you saw also from Dave's presentation, performance services and reliability services. These are connected. Connectivity is no issue there. They are safe, secure connections, connecting data and experts and serving you. They have advanced analytics, but of course there's a lot more in that area, and we do real-time monitoring with that. And provide digital services like learning from the fleet. Training modules are available, simulation modules are available. Some of these things are actually answers also to what is being discussed so heavily now, the workforce, graying workforce or aging workforce experience leaving the organization. So these are some of the elements of solutions that is already utilized. And visibility, we've been engaged in that quite a long time. Visibility to system performance, which is really now becoming more widely used also in other industries. Coming up here, when your luggage is loaded, you get a message on your phone. You get a message now where to go pick it up, and it continuously monitors and follows and you're constantly in touch with the things that we used to worry about. Is it there? Am I going to get my luggage? So that we've been doing in terms of performance monitoring for some time, sending alarm messages to your phones and emails, and so that you have instant information. And that's the urgency of data I'm talking about. Urgency really needs to be there. Now some examples. The first one is from performance visualization and benchmarking. And as most of you know that are familiar with our solutions, we always take the holistic view of the process so that we can actually do very effective optimization. And that's all in real time. So this is an example of fleet management where you can connect several machines to a remote center. And by, again, taking the holistic view, we can monitor the production, energy, and quality. This kind of thing is mostly done through well-defined key performance indices. So the driver really is the key performance index dashboards, which are in front of you. You can receive that kind of information anywhere you want, anytime you want. Especially when you pass it through some kind of alarm prioritization and warnings. That becomes a very valuable information. Machine and shift performance comparison, which leads me to benchmarking. All of those things exist now. And how do we do it? As I said, through dashboards created in Valmet Cloud and visualization through Valmet Portal. And the portal is another activity that we're very heavily engaged in, now developing it in the direction. This is, again, where we need your input. We're already piloting it, and we'd like to really get engaged in discussions with you. The direction really depends on your needs, and that's where we need to co-create the concept, the future concept. Benefits are obvious: visibility to the entire fleet, understanding and improving operational performance, productivity through benchmarking. That's a very valuable information, and long-term and short-term visibility of performance. This is an example of benchmarking where the one in the red is compared to other operations, including some average operations like liner grade average you see in the second line, fluting grade average, so that you really have a very good basis for comparing the machine and monitoring in real time what is happening to it. The next case is diagnostics, and again related to performance. This can be also done with fleet type concept or single machine. Here's an example that we have done, FormMaster with KPI monitoring. This is making sure that the strength properties and formation and uniformity is good. Where data is received from the FormMaster through an industrial router, we put that in the cloud, and then connectivity to Valmet offices and customer portal. Through this kind of means, you can get a good idea of the equipment status, the need for service, the maintenance needs. That's really where we are headed. Alarms, fleet data, and connection to, of course, Valmet, expertise center there. That way we can react faster, and we can do remote troubleshooting, and we know exactly what's happening, and we can advise you of the maintenance needs. This is really for better availability through constantly real-time monitoring of the system. And now you can really take this in several directions. It's not just limited to one equipment like FormMaster. You can do this on the presses, the reel, the winders. And the other direction, of course, is all of your machines, all the machines of the organization. So in 2 dimensions, this can grow for your organization and bring a lot of benefits. The next example, energy optimization. Now again, this all goes down to the bottom line. You can achieve significant savings in both steam and electricity through data analytics. My example here is from Thailand, PM16, which I have the machine data there, making 90 to 150 GSM recycled fluting. Design speed is 1200 and was started up in 2014. Here we have applied our solutions, and you can see the result is increasing the steam efficiency for the same grade at 125 GSM at 45 tons per hour production rate. It went up to 1.46 from 1.28. Yeah, it goes the wrong way. I switched consumption to efficiency, sorry. Okay, you see here the result is 3 million euros per year savings. And that's combined with electricity and steam. And the next case, paper quality control and variability reduction. This is again through modeling Linerboard and strength properties online. You see here burst index and SCT CD index modeling, and the green and the red, it's hardly possible to distinguish them. One is the model, the other one is the real data. So you can see there's an excellent fit between the measured and estimated burst index and SCT CD index. Again, the details are given there. A lot of tags monitored, data coming from different sources, and they all have to be synced, of course. You can't just use that data without good synchronization. And the method is, in this case, through statistical methods. We do the data analysis, validate the models, and then reduce the tags to the ones that really matter for predicting and estimating. So in this case, 10 tags. The next case is Pulp to Paper Optimizer from Stock Prep Modeling and Optimization. Here, again, measurements, of course, matter a lot. We have freeness measurement, which is called MAP, which has been recently improved in terms of its capabilities with a high-definition camera, being able to see all the properties of fiber and fibrillation indices. So using that as the heart of this application and getting data from all the other sources we need, we're actually able to do strength modeling and improve the strength properties. You can see here an example where this was applied. You see the tear and tensile qualities here. And what the data indicates is that the blue is when it's off control, so it's a big cluster spread around, a lot of variance there. And the green is after the application of this kind of thinking. So significant reduction in paper tear and tensile strength variation here, as you can see. Finally, I would like to finish with this concept here, looking a little bit into the future. I think in the future, which is not very far, looking through Google-type glasses, we'll be able to see perhaps and predict to see the condition of the machine, predict the maintenance requirements, what the machine needs, and what performance you're getting, and predict even your profitability as a result. So these things are now all connected. Thank you very much. That's my talk. And we'll continue with Rex looking at the R&D work at Valmet.
Thanks, Seyhan, and good morning, everyone. as it says up here, my topic this morning is Valmet's R&D at work. And by the phrase at work, I'm referring to the fact that I'm going to give you 4 examples of things that are in various stages of development and implementation. 2 of the topics will be things that are already out commercialized, doing quite well. 1 will be sort of in a prototypical stage, and then 1 is fully under development. And let's start with, surprise to me, a topic which Sehan just touched on. So I'll move through it a little more quickly than originally planned. If we look at our Valmet Pulp Analyzer, or the MAP system as Sehan referred to, this is a remarkable system. Does an excellent job of measuring pulp and fiber characteristics coming to the machine. And you can see that it's a system that's very well accepted with 238 references in the world and 68 in North America. What's remarkable about it is all the properties that it can measure. Obviously freeness and shive content, but look at the fiber characteristics down at the bottom of the chart. Odd things like curl and kink, and a fibrillation index with our high-definition image analysis capability. Well, these are important characteristics for making paper and board, and this is the example Sehan just showed. So a simple application of this would be in terms of specific energy control of refining, whereby using this MAP-based measurement system and process variable measurements, we can actually do much tighter control of the refining process, as Sehan explained. And you can see chart on the left is fiber length and freeness. Chart on the right is CD and MD tensile strength. In both cases, by using this technology, we've greatly reduced the variability in the process, both in the pulp and also in the final product off the machine. But imagine doing this in a real-time predictive mode, where you could take these properties and measure them with the excellent capability of the MAP system, measure other process variables, and predict and control the final quality off the end of the machine. And that's exactly what our automation guys are working on right now. So here's an example of some of the modeling we're doing. This is a plot of STFI stiffness, and we're measuring various properties of the furnish using the MAP system and measuring important paper machine process variables. And the green curve shows the actual measured STFI off the machine. The orange curve shows what our predictive model says the property should be. And you can see the agreement is excellent, very low error here. So that's remarkable that we can do that. There's another example from the same work. This is looking at Mullen or burst strength. And again, excellent agreement between the predictive model and the measured quality off the machine. So if you really want to know more about this, come to a session on Tuesday afternoon. We'll be presenting this paper using automation to predict and control board strength properties in real time. It will be presented by Greg Freilich from our automation group. It's Tuesday afternoon, 1:30 to 3 o'clock. It's a joint session of the process control folks and the recycled paperboard people. And I think you'll find that a very interesting topic. My second topic is something that's kind of closely related to this, and this is some new refining technology. This is well implemented and gaining acceptance all the time. What's special about it is we call it advanced flow-through refining. If you have old conical refiners or double disc refiners, most of you know that a lot of fiber passes through those devices without getting much treatment. And they have very low, or very high, no load energy use as well. Well, what's special about OptiFiner Pro is how we manage the stock flow through the refiner. And if you can follow these red arrows, at the bottom you'll see there are 2 arrows. We're bringing stock into both ends of the refiner at the same time. And it enters inside the rotor. And then the stock must pass through slots in the rotor to the gap between the rotor and stator. And then it has to pass through slots in the stator to get to the housing of the refiner and exit the process. So it's very difficult for a fiber to pass through this without getting treatment. And we have much more effective refining going on in this process as a result. What we get is typically a lot more emphasis on fibrillation and getting more contribution of the fiber strength to the final product quality, creating less fines, doing less cutting, definitely more uniform stock going to the paper machine. And ultimately, we find that it has a very low no-load power requirement, so it's a much more efficient process as well. Here's an example of the strength development. It's a tear and tensile, combined tear and tensile plot. If you look at the green and brown curves at the top, those are OptiFiner Pro. The black and gray curves below that are traditional refining. And the key is for any specific energy level along the x-axis, we're getting a lot more fiber development with this type of refining. One of our first references was at a mill in Austria, where we replaced 3 double disc refiners with 1 OptiFiner Pro. And one of the first things they saw was huge power savings in refining, 24% gain there. And then this chart shows some more comparisons, and the change percentages in the right, or on the right, are shown in green because they're all positive things. So not only did they save power, but they increased production by over 50%, reduced the specific energy requirement to accomplish this refining, and you can see the gains in breaking length and tear strength as well. So over 70 of these have been sold so far, and I like to think of something like this in combination with the MAP measurements and the real-time predictive modeling we can do, and some of this is going to come together very nicely. My next topic has to do with a new approach to gap forming for containerboard, and we call it OptiFormer Gap with shoe blade forming. If you look at the trend in containerboard forming concepts worldwide for about the last 20 years, we see that overall basis weights worldwide are tending to go down. Machine speeds are going up. There's more use of recycled furnish, and the quality of recycled furnish is getting worse too. And if you look at the forming concepts on this trend chart here across the bottom, on the left side you see multi-four-denier or four-denier-based forming. Has overall a higher basis weight capability, but typically slower speeds, max speeds of around maybe 3,800 feet per minute. Over on the right side of the chart, an extreme are the gap formers. These are the fastest machines in the world, up to 5,000 feet per minute. Most of them are on recycled machines with size presses as well. And of course, the reason for that is also the characteristic MD-CD fiber orientation associated with these processes. So four-denier on the left side, you can see the minimum gets down to about 1.7 ratio. And typical roll blade gap formers maybe can get as low as 2.5. And of course, that's a detrimental thing when you're aiming for CD ring crush or CD stiffy, that sort of thing. So what if we have a concept that's somewhere a tweener, if you will, and that's what I'm talking about. So with this OptiFormer Gap with shoe blade technology, you can see on the left side we have a 2-layer head box feeding the gap between the top and bottom fabrics. And what's most important here is we're doing less aggressive initial dewatering than what we would with a suction roll in a conventional gap former. Right after we get past the gap, we've got a 2-chambered curved vacuum shoe on the bottom. On the top, we have a 4-chambered suction unit with 21 blades at the back end of it for doing pulse dewatering as well. But the initial formation of the web takes place very quickly, but without pulsation. So we're getting very nice surfaces formed, very, very good retention, excellent formation quality. And then when we've consolidated the web a little bit more, we're hitting it with the pulsation drainage. You can think of it a little bit like a hybrid between a hybrid and a gap former, if you will. And what we see, what's a nice feature of this, is the MD-CD ratio is reduced. We can get down to 2.0 with this technology. Looking at another comparison we recently put together for an example of 222-inch reel trim making 19 pounds per 1,000 square feet recycled liner and medium. You see on the right side of the chart, in terms of speed, capability, and production, a 23% gain with this new type of former. But it's also noteworthy that it takes a lot less power for the approach flow system and the forming section. We see about a 40% reduction in the electrical power requirement for this kind of section. And you can see, obviously, just looking at it, the length difference. In this particular example, the forming section is about 60% shorter than the four-denier section. So those are also pluses. The minimum down at the bottom I have in red is, again, the MD-CD ratio is not quite as good. Well, what can we do about this? Well, as I said, most machines of this sort in the world now have size presses, and actually there's an increasing trend to size press use in North America as well. But something else we can do is we can use our Aqua layering technology. So on the first slide, I showed that this is a 2-layer head box. Well, in between these layers, we have a water layer that we can put in there. And that can be used to do for good layer separation if you have to do different furnishes. But you can also put starch there. And it's a much more effective way to put starch into the web to strengthen it than putting it in a machine chest, for example. So I think what we see is that, you know, with this higher speed capability and lower MD/CD ratio, and also thinking about using aqua layering with starch and perhaps size press, we have a pretty interesting example of a new way to make containerboard. We've sold 3 of these forming sections so far for containerboard. None of them have started up. 2 of them are on rebuilt machines, and 1 is on a brand new OptiConcept M machine, which will start up this fall in Italy at Proget's Mantova. And you can see that it's about a 300-inch wide machine with a design speed of 5,600 feet per minute roughly, making 15 to 33-pound recycled liner. I think it's going to be interesting to watch these startups. We're starting to see a little different trend in how we go about making containerboard at very high speeds. Let's move to the dry end for my last topic. Let's talk a little bit about winding. Anybody out there wish that they could prepare parent rolls with less waste, faster, and more safely? Yeah, I see some heads nodding. And does anybody have a need to increase winder capacity? Yes. So that's what I'm talking about. Why not a winder with 2 unwinds? You may wonder what that means exactly. If you look at the different ways to increase winding capacity, this list here, we do all these things all the time. But in particular, things like decreasing set change time, increasing accel and decel rates, making very large parent rolls to improve capacity. These are all big pluses, and you can see the relative percentage gains over on the right side. But look at the bottom line. Using a dual unwind, fully automated with automatic splicing, we can get capacity gains of 10 to 30% or even more just by doing that. This is the section I'm talking about here in this hash mark area. You can see the 1 parent roll that's running into the winder right now, and then immediately behind it, the next parent roll. We're talking about both of those. There's also an electric carriage system there to automate or automatically move the parent rolls around, and a splicing system as well. We've sold 21 of these, and roughly half of them are in operation. Here's how it works. The winder's over on this side of the screen where I am. And when we get to the second to the last, end of the second to the last set going through the winder, and we come to a stop, during that set change, the parent roll, which is over on the left, in this, at the top left picture, gets automatically transferred to a primary unwind position to the right. And then while we're running that last set, a suction roll reaches up and grabs the tail of the new parent roll and brings it down to a lower position at the bottom left to get ready for splicing. And so while we're decelerating from the last set, this is bringing the tail down and getting it ready. And then we have an automated slicing system, 0.5 on the slide. We're actually making that splice. It's a butt joint splice taped on both sides of the web when we come to a stop, and we're ready to run again. And with this process, we can do a parent roll change in about 1 minute. Here's an example for linerboard, 29-pound linerboard on a winder that's pretty fast, 8,200 feet per minute top speed, pretty good high accel and decel figures, and pretty good set change time too. But if we reduce from a typical parent roll change time with an experienced crew of maybe 6 to 8 minutes down to the 1 minute area, we're increasing the output from that winder from almost 1,100 tons per day all up almost to 1,400 tons per day. That's a huge gain. And you wonder if this has been proven. Well, the first proof of it was at ProPapier in Germany on their PM1, where we have this dual unwind and splicing technology. This is the highest capacity winder in the world. One winder keeps up with a paper machine that runs up to 1,700 meters per minute. It's a world speed record holder, making recycled liner medium. This is also a very advanced winder in other respects, but the parent roll change is a big part of it, and they achieve 1 minute parent roll change. So I hope you've seen that these 4 examples are things that are worthwhile technical developments. Dave talked about our R&D organization some, so I won't repeat that. But a couple of these metrics I want to point out. As he said, we have R&D spend over 60 million euros a year. He talked about the 16 centers. Many of you have been to our pilot plants and run trials with us. If you look down in the bottom left corner, you see that over the last 40 years, we've run over 10,000 pilot trials. And this is our own work, but it's also our work with our customers. So Valmet is very much committed to R&D. It's a key part of our success. We think it's a part of your success as well. And I hope you enjoyed those topics. With that, I'll introduce Mike Gray, who's going to talk about grade conversions.
Thank you, Rex. Good morning, everyone here in person and those of you on the webinar as well. This is always an event I look forward to, the breakfast seminar. It's an opportunity for Valmet to showcase some of the abilities we have, what we're working on for both today and the future, and to interact with everybody up here. I'll touch on R&D again. Maybe it's a little bit of my engineering background that comes out. I could listen to Sehan and Rex talk about R&D developments for most of the day, but we only give them 15 minutes. Investing 60 to 70 million euros per year has been a tradition for Valmet for a long period of time. And I'm very proud to work for this company because of that, because I think that investment in good times and bad leads to innovations for the industry that will make you successful. And if you're successful, we'll be successful as well with you. And that's really our goal, is that we want to be strong. We want you to be strong. And that will make all of us much more happy in the future. One of the other exciting things for me here at PaperCon is relationships, and certainly working with customers here that I've known for many years, working with colleagues that I used to work with in previous careers, and that is always fun to have some of those conversations, and I've had a few last night and this morning, and it's kind of interesting. We used to talk about the new children we were having and those types of events. Now we talk about where our children are working and what they've done after they've finished up their schooling and that. So I don't know what happened during those 20 years, but the conversations have changed quite a bit. And I've noticed we still talk about children, but it's grandchildren now, not children any longer. So we've all grown a little bit older. And when you have those conversations, I think we all remember the days you'd open your wallet and you'd unfold this accordion of pictures of all your kids and grandchildren. Nowadays, we pick up the phone and we go to our camera roll and we start talking about our children and grandchildren with a camera roll. It's not a big surprise. Digitalization is taking over our world. It has been for well over a decade, 2 decades now probably, to be a little bit more accurate. And it's had a huge impact on printing and writing grades and newsprint grades. And it will continue to do that. You know, I think one example in the newsprint grades, in 2000 there's about 13 million tons of newsprint capacity in North America. And now it's down to about 4 million tons. So a huge drop-off. And I listened to one analyst, industry analyst, here just a few months ago in a presentation talk about newsprint within a 5 to 10 year period potentially going to zero in North America. So I don't think it's a surprise, but that really hit home for me is how fast that decline's going. Newsprint still drops at 8 to 10% per year from a demand standpoint. The printing and writing grades, it varies, whether it's uncoated wood-free for copy paper, or whether it's coated paper for magazines and that, but anywhere from 4 to 8% depending on the specific grade. So that will continue to go down. We've seen the impacts this year. We've seen 2 machines at Thole that are indefinitely shut down, newsprint machines. We've seen Kruger, which we'll talk about a little bit up in Three Rivers, going through a conversion right now from newsprint to containerboard grades. And then there's a project up in Sappi that we'll talk a little bit as well about here shortly, going from uncoated wood-free to containerboard grades in early 2018. So it's happening, and what we need to consider is some of those assets are very, very good assets yet. Big machines, quality machines, what can we do with those machines? Kind of a new aspect, and we saw this at Resolute and Calhoun, is maybe a mill conversion more than a machine conversion, because you can't make tissue very well for most of the tissue grades on a typical paper machine. But at Resolute, they just started up here approximately a month ago, a tissue machine at the Calhoun mill. So they're using some of their pulp capacity that they have there to completely get out of that grade and into the tissue. And I expect in the coming months you'll see another traditional paper producer make that same change as well and start to move more into producing tissue type grades. It's a growing market. I think as Dave mentioned, tissue and board continue to grow. Tissue probably around 2% per year, and the containerboard in North America 1 to 2%. It's changing quite a bit as we go into the world of Amazon and the boxes are smaller. They're direct shipped a lot of times. They're not going to the big box stores like Walmart anymore, so that's putting some stress on the machines as well. The second one here, paper to specialty grades, maybe I should have said paper to pulp. Dave mentioned Domtar. We just did a conversion there at Ashdown, and if you go back over the last few years, the Domtar machine at Plymouth, one of the machines there was converted to pulp. International Paper has also converted a couple of machines at Franklin and Riegelwood to make pulp. So that is certainly a growing or continuous, maybe not growing, but a stable path for some of those old machines that make paper to move into those grades. And then paper to board. There's several ways to do this. If you have a paper machine, I think if you look at what is now Westrock down in Dublin, it was SPFT at the time of the conversion. They put in an OCC plant and didn't do many modifications to the machine. There's other examples that we'll talk about where there's quite a bit of modifications to the machine. And it depends on the configuration of the machine and what's installed there, what needs to be done to make it go forward. Valmet's been involved in several of these larger conversions globally, as well as here in North America. As I mentioned, a big part of that is our technology people and our R&D capabilities. So when a customer is considering what to do for a grade change, first of all, the need is kind of market driven. As those digitalization takes over, a lot of those paper grades are less needed, so there's a need to change. Analyzing the existing machine. What does the existing machine have? What production volume do we need off the machine? And what quality properties do we need off those machines are really the two key driving points going forward. We've got a lot of experience in these grade conversions. We've got the research and development capabilities, so we can analyze both the pulp at our research facilities, sample the pulp, look at it, whether it's going to be some type of virgin pulping process or more likely a waste-based OCC process, analyze that, run that on our research machine, look at different configurations, look at different technologies like some that Rex and Sayan talked about from a control standpoint as well as from a machinery standpoint to say this is what's needed to make the final sheet properties that are going to be necessary to be successful. During the project phase, we certainly have done a lot of big and small projects throughout the world to make sure that what we have agreed to in the specifications is smoothly delivered, installed, and started up successfully, and then work to get a fast payback. You know, we want our machines to start up and our rebuilds to start up to get to that high production level and good quality level as soon as possible after the rebuild or the new machine installation. And that's key to returns. We'll talk about that again here a little bit later on. I talked about our research and development facilities, mechanical pulping, waste paper pulping, certainly a couple of our strengths that we have in our research facilities, mainly located in the Scandinavian countries, Sweden and Finland. It's interesting, if you look at the capital market for Valmet, 2015 was a very strong year. 2016 was a little bit low. Just the overall North American market, we had very good market share, but the market was a little bit down in 2017. The activity level is extremely high, both for new machinery and rebuilds, mainly again on containerboard and tissue. One of the I think the neat points that I've seen from a research and development standpoint is if you look globally, our R&D facilities had more days from North American customers than any other region in the world last year. So we have a lot of customers here locally in North America that are looking at their installed base and figuring out what they can do and running trials with us, either on a sectional piece of equipment or on full machines. Our two pilot machines, again, from stock prep up through the drying and then reel it up. And then that would be mainly in our Uvascular facility, and then down in our Yarbenpot facility we have complete finishing capabilities, calendering, coating, winding, et cetera. So very, very extensive laboratories, very extensive analysis capabilities, whether it's with our fabrics division or with our machinery divisions. We can analyze what's going on at the mills, what's going on with your paper, and make recommendations how to improve it. I'll talk a little bit about blue paper, and I know this is not a North American reference, but I think it highlights a lot of what is happening with respect to grade conversions. This is actually the second time this machine has been converted, and this particular one was going from fine. Originally went to coated magazine and then to liner and fluting. It follows a very similar trend to what I've been talking about here and to what we see the customers doing, where we run trials with the customer. They say, you know, we've got to do something else. We analyze what the machine is, what can be done, and then we sit down and run trials to confirm our thinking and to help the customer in developing what they can make on that machine and understanding what they can make successfully. We also do safety audits quite a bit, especially as Rex mentioned on winders. Winder safety audits and safety upgrades are vitally important to our industry. It's a cornerstone of what our values are at Valmet, making sure that we are safe and that we're providing equipment and services to our customers that help improve their safety as well as keep everybody safe. So this is the rebuild that was performed there, and again, it kind of highlights all the thinking. First of all, the headbox. In this case, we relocated the headbox, so a minor modification there. We've done a lot of work. One of the issues I think that we've seen with gap forming in North America, the fiber's long. It's hard to get MD/CD ratio, as Rex mentioned. It's also hard to get capacity. So we've developed a lot of products in the landing area of the forming zone and the forming zone itself to make sure that we can best control that MD/CD ratio and gap formers, as well as get the drainage capacity. A lot of it depends on your furnish, but in general, a gap former would be applicable in North America. I'll say from a 35-pound and below, you can get up a little bit higher than that, but then your production rate starts to go down. So for high production basis weights, it's probably not the right former here in North America, but if you go to lower weights and want higher speed, it certainly is a very good way to make paper. And at SPFT, that's a gap former. The Kruger project is also a gap former, modified off the original Valmet that's there. So in the pressing area, again, it's strength and it's production level. So pretty much you're going to need a shoe press, I think, in most of these cases. You can start up without one, but it's kind of a handicap for you if you don't have a shoe press. And that was already existing on this machine, so it was not added there. In the dryer cans, when we talk about grade conversion, if you look at a lot of those newsprint machines and paper machines, the dryer cans are only rated for 75 or maybe 100 PSI. If you look at typical containerboard machines, you're going to be in the 150 or 160 PSI range. So if you don't have high-rated dryer cans, that can, again, be a very limiting factor from a production standpoint, and certainly considerations need to be made to change those dryer cans to get their production levels up. And that's a case-by-case simulation that we can do. More and more common, size presses. A lot of on lightweights, you'll see a lot of the metering size presses kind of taking over in the industry. Not too many pond sizers being supplied anymore. But that is something that when you look at gap forming, you look at developing strength, that is one area that can be a focus as well. And then the after-size dryers. In this case, there may or may not be, depending on the actual application and the actual equipment that is installed at the mill historically, a need for some reel modifications or winder modifications to handle the heavier basis weights, typically with containerboard grades versus paper grades. And we certainly have the capabilities to look at those as well. So this machine has started up. It's been a very good conversion for the customer and has been running very well. I talked about North America, and one of the reasons I focused a little bit on the blue paper job is we do have two big conversions going on here in North America right now. At this time, the customer has asked us not to release the drawings or to show the drawings publicly, so I'll be talking through that a little bit, but I certainly want to maintain that confidentiality that the customer has asked us to. So the first one, Kruger and Three Rivers, typical 330-inch Valmet making newsprint machine. Design speed's quite high. This is shut down right now, and I expect the startup to be during May. So that machine's been down for a couple months now. Huge conversion, again, covering headbox through winding. So it touched virtually every part of that machine in some way. and that will start up here again in about another month. The second one that I want to mention briefly is Sappi at Somerset, wood-free coated machine, #1 machine up there. That's being converted to packaging grades as well. That one was just started here a few months ago as far as the process of engineering. So we're late in the phases of engineering. We'll start manufacturing of the equipment, delivery late this year, and then a startup early in 2018. So 2 large projects of conversion from paper to packaging grades. And we're hopeful that we can have those customers visit us here next year or the year after to talk about the success of those rebuilds. I think it's great as part of this to have a customer testimonial as well. They went through the same process that we've been talking about all along. A lot of detailed discussions, a lot of research and development work to test the process and make sure the paper qualities can be met. Speaking of customers coming, we had Jay Hennessy at the meeting last year for our discussions here at the breakfast seminar from Valparaiso. I just wanted to go a little bit and show you the success they have there. This is a complete new machine down in Valparaiso. What you see here in front of you in the green is their actual production on a monthly basis. The next line down in blue is what they budgeted. So somewhere close to 200 tons per day above their startup curve is what they've been able to achieve in the first, this is 17 months of operation. So quite successful, and I think you can understand the financial impacts of being 200 tons per day above your startup curve. So it's been highly successful, primarily from the customer standpoint, and certainly Valmet's very proud of being part of that and having the opportunity to discuss that with you. With that, that concludes, I guess, our presentation portion of this. As was mentioned at the start by Dave, we do have some time now to address a couple questions, either from those in the audience here or if there's anybody online for the webinar. If you have questions now, we'll try to address those. Okay, the question I have here is what can be done to increase paper strength properties for grade conversions with gap formers? I think we've touched on a lot of those. One of the key developments that Rex touched on is the Aqua layer headbox, where we can, between 2 layers of paper, we have an Aqua layer, which can be water from a strictly separation standpoint between the plies. We've also done a lot of work both internally and with customers of looking at what else can we put into that middle layer, whether it be starch, whether it be some type of highly refined fibers to increase the strength properties. And one thing you find with the Aqua layer, if you can, we've all, I think, are familiar with putting starch back in the beginning of the process in the pulping side of it. If we can put the starch in the middle of the layer between two separate plies, our retention value of that starch goes up significantly. So we can both retain more starch, and if we retain more starch, our strength properties also increase quite a bit. We also talked about some of our forming developments, and the pressing. Shoe presses are pretty standard in the industry right now, going down the machine. What we do is sizing, and we continue to develop our sizers to enhance runnability and strength properties using combinations of metering sizing. We also look at spray sizing and other items to help enhance the strength properties as well.
I have one here that Ward passed to me, I guess, from the webinar. Says that I mentioned excellent formation and uniformity when I was talking about the shoe blade gap former and just how good is that. It's a little bit hard to say for sure because, as I said, we have sold 3 of these, but none of them are in operation yet. But from the pilot work we've seen, we measure formation using beta formation measurements. We've seen results down to about 0.7 beta formation, which is an excellent result for the normalized value. We would expect in terms of uniformity, I said it has a dilution headbox on one of the plies, or excuse me, dilution profiling on one of the plies, and typical of gap formers, very high retention, very high uniformity, and very low residual figures. So I guess I'll dodge that a little bit and say we would expect that uniformity or those uniformity characteristics typical of gap formers to be the sort of thing we'll see here too. Yeah,
how transferable is the example I gave with MAP? It's actually very transferable. In fact, one company is looking at multiple implementations of it. I think if you do the project with that in mind, it's quite transferable.
Yeah, it definitely has to be done for each machine because all of those independent variables that we use, thank you, all of the independent variables that we do use, both, the one thing, of course, that is the same as the measurements from the MAP and the locations, generally speaking, where we measure from and the type of properties. But, of course, the other very, very key variables from the process itself are fairly, some of them, of course, are very transferable across the board, some of the things, but there are also specific things to each machine that we use to get a good correlation and a good model built.
Yeah, I think you can probably hear the question was asking with the OptiFiner Pro, are we seeing improvement in the fiber characteristics, not just, say, reduction of no-load power? And absolutely. Much better and much more uniform fiber development. We've even had some customers to try to do some unusual things that I won't talk about with the refiner, but it's a much more versatile refiner and overall, let's say, preserving the inherent qualities of the fiber better than classic double Ds or Claflins or what have you.
Yeah, I had a question. Dave, I think, mentioned earlier about Valmet had a couple of hiccups over the years. So I was just wondering if you could maybe state one of those major hiccups, not so much to bring up a bad mistake, but just to bring up as a learning opportunity. And what did you do to ensure customer satisfaction?
Yeah. Well, of course, I guess all companies have some types of issues and so forth, and you know it's hard for me to call out a specific example right now. But what I could say is that generally speaking, we have an extensive quality process, which includes a continuous improvement program and tool. And what we've tried to do is to bring the customer into that process and to show and to work together to make sure that we're not only improving our processes to, you know, eliminate that same type of problem from happening again, but also to ensure them that we're taking it very seriously and working through the issue and coming up with permanent solutions. And it's been pretty well received, and I think that sometimes the issues can be created in a joint aspect, so to speak, and the customers have grown through the process as well and seen some better results and so forth. So hopefully that kind of answers it a little bit.
For the advanced analytics and such that you're doing, are these mainly on new machines, or what would be required to get that kind of capability on our older traditional 60s and 70s Beloit machines?
They are really not limited to just the new machines. It can be done with the older machines. Of course, when you look at the older machines, some upgrades may be needed, especially to the automation side of the equipment in terms of connectivity. But I think we've seen over the years that requirement exists also when you're trying to really just upgrade the automation side. You have the same requirement because of the vintage of the system. So it's really dependent on what is there, especially with respect to automation equipment. But I think most of us here are familiar with the connectivity side. That's the biggest bottleneck.
Back to your model, I'm assuming the model you showed across various basis weight ranges. How does your correlation hold up when you're just looking at one basis weight?
Well, it depends to the particular method we're using, of course, but the modeling and validation phase includes looking at a wide spectrum of situations, at least, the extremes. Just like in sensor calibrations, unless you really have looked at the ranges, you may not get the result you want. unless, of course, in sensors it's easy because a lot of the times you can take this kind of dependencies out. And we do the same thing with control implementations. We try to base our models not so much on things that can change, but more the basic elements like the machine geometry and typical usages of fibers and furnish and things like that. So that's a little bit hard to address because it's so much dependent on the modeling work and the method used. We have used several different methods, but most of them really, if you look at the types, they go back to some kind of finding the most influential parameters in the model. And correlations are much better if you're able to do that. And there are various statistical as well as deterministic methods to do that. You know, singular value decomposition is one of them, which gives excellent models. So it just depends how much validation work has been done.
Okay, I think we're pretty much out of time, and out of respect to Tappy as well, we've got the keynote address coming up, and for those of you who are wanting to get to that, we'll cut the official program off now. Again, I'd like to thank everyone. Really appreciate you coming out this morning. I hope it was a good benefit. Thank you, everyone who was online as well. We really appreciate you participating. Certainly, the guys will be hanging around a little bit if you have any other questions you'd like to take offline. And, of course, if you'd like, visit our booth, and some of the guys will be around to catch up on any specific other topics that you'd like to touch on. So thanks again, everyone. Really appreciate it. Looking forward to a good show.